All right, let's do the sample test. First question, convert 7 pi divided by 5 radians to degrees in decimal. Okay, so when we're converting, we're going to either multiply by 180 degrees is equal to pi radians, or pi radians is equal to 180 degrees. One or the other. And since we want the radians to cancel, we're going to put radians in the denominator. And pi radians is 180 degrees. So the pi's cancel. 5 goes into 180, let's see, 3, 30, 36. So 7 times 36 will be our answer, which is 252 degrees. Okay? And now the second one. Change that into degrees, minutes, and seconds. Well, I should have picked something a little bit different because this one's pretty easy. 252 degrees, 0 minutes, 0 seconds. So let me do a different one here. Let's say 7 pi over 11 radians. So that would be, I'd have to multiply that by 180 over pi, and the pi's would cancel, and I'd get 7 times 180 divided by 11, and I get, oop, I didn't do that right. Excuse me, 7, I did 7 divided by 180. 7 times 180 divided by 11. That's 114 degrees, 0.5454 repeating. So for this one, if I were doing this one, then I'd say I have 114 degrees. Subtract the 114 from my answer, and I'll get that 0.545454, and take that times 60 to get the minutes, and that comes out to be 32 minutes. Comes out to be 32.727272. So then I will subtract the 32 minus 32, and I get that 0.727272, and I'll take that times 60 to figure out the seconds, and that comes out to be 43.6 rounded off seconds. Okay, so my original one came out a nice even number. That would have been it. So here's a second one that would show you the steps for doing one that might be more like what's on the test. Now we're reversing it. Notice this is a negative angle, so we've got to be careful here. It means that's negative, and that's negative. It's all negative. To degrees in decimal. So I've got negative 223 degrees, and then I got also a negative 43 divided by 60 degrees, because there's 60 minutes in a degree, so 43/60ths of a degree, because 43 out of the 60. And then also negative, minus, and this is 10 out of how many seconds in a degree? And that's 60 times 60, or 3,600. Nope, I forgot to put the divide in there. 10, insert divided by 3,600. 10 out of 3,600 seconds is how much of a degree that is. And I get an answer that is, so I'm doing negative 223 degrees plus a negative, or minus 43/60ths of a degree, and since it's all minus, also minus 10/3600ths of a degree, which comes out to be negative 223.7194444, repeating. Now if I want to turn that into radians in decimal, so I got this in degrees, so I want the degrees to cancel, so I'm going to take that answer times, I want radians, so I'm going to multiply by radians, which is pi, over what it's equal to in degrees, 180. So I have to take my answer divided by 180, and then I can write it with a pi. I'll just divide by 180. And that would be negative 1.24 blah 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 pi radians. But it says in decimal, so I'll have to multiply that times pi, and I get negative 3.9046 radians. Okay. Give the exact value of no decimal approximations. So 3 times the cosine of 45, and we from our special triangle know that's either 1 over the square root of 2 or square root of 2 over 2. 45 is in the first quadrant, positive. Minus, so that's times 4 times the tangent of pi, 5 pi over 6. So that's pi over 6, 30 degrees, 5 times 1, 2, 3, 4, 5. It's over here. The tangent would be the sine, which is 1/2, over the cosine, which is negative square root of 3 over 2. So the 2's will cancel, and so I get 3 over the square root of 2 minus a minus, which is plus 4 over the square root of 3. And now I could get a common denominator by multiplying by the square root of 3 here and the square root of 2 here, but that would be good enough for me, just like that. That's exact value. I cannot use the decimal, I can't use the calculator and get decimals with it, because I said no decimal approximations. If you're able to rationalize that, let me go ahead and do that. That would be square root of 3, square root of 3, square root of 2, square root of 2, and I would have 3 square roots of 3 plus 4 square roots of 2 over the square root of 6. And I haven't rationalized yet, so then I'd multiply by the square root of 6 over the square root of 6. And I would get 3 times the square root of 18 plus 4 times the square root of 12 over 6. And 18 has a 9 and a square root of 2, so that would be 9 square roots of 2, 3 times 3 square roots of 2, plus 12 has a 4 in it, which would come out as a 2, so I'd have 8 square roots of 3 over 6. But you could have just left it like it was in the original problem, which was 3 over the square root of 2 plus 4 over the square root of 3. Number 4. The sine of 2 radians. So if I look at the unit circle, 2 radians is, 1 is about here, 2 would take me over here, 3 takes me just shy, because it's 3.14 is pi all the way here. So 2 radians is somewhere about here, and the sine would be this height. And then it says the sine, divide that by the sine of negative 2 pi, which is down here, and the sine of that would be the same size but negative, and so I would get some number for the sine of 2 radians divided by, and the negative actually comes out of a sine, negative sine of 2 radians, and these would cancel and I would get negative 1. They're equal and opposite, so the ratio would be negative 1. The division would be negative 1. Okay. It says if the cosine is negative 12/13, see, the cosine would be, if I make the unit circle, cosine is negative over here, and it's negative 12/13, so it's almost negative 1 on the unit circle. Negative 12/13. And the sine is positive, that means we're here, and we got here, and this side's 12/13 negative, this is 1, so to find the sine, we'd say sine squared of the angle plus the cosine squared of the angle is 1. That's our Pythagorean theorem in trig. So the sine squared of the angle equals negative 12/13 squared, which is plus 144, because the negative 12 times negative 12 is positive, over 13 times 13 is 169, equals 1, but I'm going to have to subtract 169, so I'm going to write this as 169 over 169, getting a common denominator. So if I subtract 144 169ths from both sides, I get the sine squared of the angle to be 169 minus 144 is 25 over 169. Take the square root of both sides, and the sine can be either plus of the angle, it can be either plus or minus 5 over 13, because the square root of 25 is 5 and the square root of 169 is 13. But we said that the sine has to be greater than 0, so we're throwing out the negative answer. And so the sine of the angle is 5/13. And therefore the tangent, which is sine divided by cosine, and if I multiply numerator and denominator by 13, these 13's cancel, and I get negative 5/12. And the secant is the reciprocal of the cosine, and the cosine was negative 12/13, so the secant is negative 13/12. Okay, that's page 1. Page 2. It says graph this. Give the requested information of the graph and explain the transformations in the table. So I'm going to have you explain them and not do graphs of each one. But what's the amplitude? Well, it's the absolute value of this coefficient here. So the absolute value of negative 3 is 3. Period. Well, normal period for the sine is 2 pi, and I divide it by whatever's times the x, and that's pi over 3. Divided by pi over 3. So if I invert and multiply by 3 over pi on the numerator and the denominator cancels, and I get 6 pi divided by pi, which is just 6. That's the period. And then there's no horizontal phase shift translation of this translation, because there's nothing added or subtracted to the x, but there is a vertical translation of up 1. So now we go through and explain each of them. The negative on the amplitude is on the outside of the parent function, so that's a vertical flip. reflection. The 3 triples or multiplies the amplitude by 3. The pi over 3 makes the period be, changes the period from 2 pi to 6, which is, see, and that's really not very much different. 2 pi is a little bit bigger than 6, so it did a slight compression. Slight, if you wish, S-L-I-G-H, horizontal compression. You could use that also. And the plus 1 translates it or shifts it up 1. So, to draw my graph, our period is 6, so I'm just going to mark it off 1, 2, 3, 4, 5, 6. And -1, -2, -3, -4, -5, -6. So I did that instead of pi because the period is this kind of a number. And it's a sine, and the sine normally starts at the center and goes up, but since it's negative, it's got to go down. That vertical flip. But it also needs to be moved up 1. So I'm going to call here the center line, because that's up 1 from where it normally is. And if I call that 1, and this has an amplitude of 3 above the center line and 3 below the center line, it's got to go clear up to 1, 2, 3, 4. It's got the tops have to be up at 4, and the troughs have to be down 4. 1, 2, 3, 4, which is at -3. Oop, and I didn't go up 4. No, down 3, excuse me, down 3. So that would be at -2. So there's where the bottom, there's the top, 3 either side of the center line. It's a sine curve, which starts on the center line, normally goes up, but this has got a negative, so it's flipped over. And by 6, it does a full wave. So if I'm going down here, I'm ready to go down here, so I'm coming down to this. And if I go halfway between, it's back on the center line. So it has to go down at 1.5, be at the bottom, then back in the center, and then 1.5 further, it's at the top, then back at the center. And I can go backwards here and do another wave back here. 1, 2, 3, it's at the center. 1.5, it's at the top. 1.5, 1.5 is here at the top and back down. Get it right here. At the top, center, 1.5 down at the bottom on the -2, and then back to the center up here. So boom. And you can type that equation into the calculator and make sure you've got it correct. Okay, so that's what I'm kind of expecting you to do on number 6. Look at all the things that make the adjustment, explain these, explain what's going on here, and make the proper graph with it. Make sure you show the units on the graph. Okay, and now we got this one. I said just graph it. Okay, now if you ever have to do secant or cosecant, graph the cosine or sine depending on what you're doing. Secant is 1 over the cosine, so you should graph y equals 2 cosine x minus 1 first. And now the period, since there's nothing added or multiplying by the cosine inside the thing, then we're going to have a normal period. So I'm just going to write down here, I'm going to go out here 1, 2, 3, 4, and make that be pi. 1, 2, 3, 4, and that'll be 2 pi. Halfway between be pi over 2 and pi over 2. 3 pi over 2 and pi over 2. And going the same way, 1, 2, 3, 4. 1, 2, 3, 4. That's negative 2 pi. The amplitude is going to be 2, but we're down 1. So the center line, I'm going to, again, like I did up there, I'm going to make every 2 be 1. So there's negative 1. There would be the center line. And then it's got to go 2 below that, so that'd go to minus 3. And up 2, which would be 0 plus 1. Cosine, so it starts at the top, goes at pi over 2 is at the center line. At pi, it's at the bottom. And then halfway back, it's on the center line. And then it'll be back at a crest. And we can do it back here. So it's a peak, and it's at a peak. Halfway between, it's at the bottom. And halfway between these two, it's in the middle. Oop, on the center line. And then on the center line, halfway between, it's in the middle. And so I'd be looking for, so that's the cosine. Now let's do the curve they asked for, which would be anytime this is on the center line, that would be where an asymptote is. Center line here and here. So the secant will be reciprocals. They'll be used on top and on the bottom of this. So it would go off the crest here and go up. And they'll be going up here. And another one up there. And one going up there. And so on over here. And there'll be ones on the bottoms going down. Yeah, there's the asymptote. So there's not this curve. These are the secant, the reciprocal of the cosine. Okay, that's page 2. Now let's look at page 3. Now it says, write the equation for what's already graphed. Well, let's see. First thing I want to know is what's the lowest place. That looks like it's 0.5. Highest place is 1.5. So the center line must be halfway between 0.5 and 1.5, which is 1. So I know this curve has been moved up 1. Now let's look at the period. Well, it's crossing 1.4 at 0, so the next time it crosses and going up at 1.4 is at 2. So that means it repeats itself every 2 units. So the period equals 2. And it looks like it's shifted. It's not right on the center line starting at 0. So we have to do a little bit of thinking here about which graph we're going to use. And since it's almost at the top at 0, I'm going to use the cosine. So if I write y equals cosine of x, that would start right at the top and go down and back up. But to make it have moved up 1, I'm going to have to add 1 on the outside. To make it have a period of 2, I'm going to write in front of the x 2 pi divided by 2. So I'm going to scratch this one and say, okay, to get the right period, I'm going to have to write cosine of 2 pi divided by what the period is, 2 times the x up 1. And these 2's would cancel, so it'd just be pi x. And that would have a period of 2. And to check yourself, you always take the number times x and divide it into the normal period. Normal period for cosine is 2 pi divided by pi would have a period of 2. So that checks out. It also has an amplitude of 0.5. So I got to put 0.5 here, and I don't need this to be negative because I want it right side up. I don't need a phase. I got the right period. I got it pushed up right, but it slid over a little bit. So I need to change this equation one more time and write y equals 0.5 cosine parenthesis, and as we talked about on Monday, we do pi, and then I can do in separate parentheses how much I want the curve move sideways, and it looks like it's about 0.2 over, so I might go x minus 0.2. I think I actually did 0.25 on this, but I'll just leave it 0.2 plus 1. So anything close to that. I think that's what I actually did to make this equation, but as long as you've got stuff that makes sense here, that would be fine with me. So there's a lot of thinking into writing the equation from the graph. So I hope you take your time and do a good job on that and figure out how to do that well. Now here, I'm trying to make one of these curves, which isn't a cosecant or secant, because they're not used. It's either tangent or cotangent. And since it looks like the center line is right here, there's an asymptote here, halfway between it should be on the center line, which is right on the x-axis, so it's not moved up or down. Since it goes through 0 instead of the asymptote being on the y-axis, when it's not on the y-axis, it goes through 0 on the y-axis. That means it's a tangent. Or that's what easily can be done. However, the tangent goes from negative up to positive instead of positive down to negative as you move left or right. So this must be the tangent flipped over. So it's going to be negative tangent. Now let's check our amplitude. Now we find the center line by going halfway between asymptote and asymptote, gives you where the center line is, and that was right on the axis, not moved up or down. And then if you go halfway between where it's on the center line and the asymptote, you get an amplitude, and it looks like it's down 1/2. And so instead of up 1, it's down 1/2. So there we got the negative and the 0.5, confirming that it's an upside down tangent. And then the period. Well, the normal period, asymptote to asymptote, or from x-intercept to x-intercept for a tangent, is normally pi, but this one is pi plus pi. It's 2 pi. So it's stretched out. And so it's not 2 times x, because that would shrink it. So it's got to be 1/2 x to make the period be 2 pi. Now remember how you calculate that? You take the normal period, tangent's normal period is pi, and divide it by the coefficient, which is 1/2. And if you invert and multiply, you would get 2 pi, and so that checks. So there, and it's not moved up and down, so it's plus 0 on that side. So there is the equation for this curve. And you can always type that into your calculator or your Desmos and make sure it looks like this. you want to put your units as pi over 2 to make sure, and 0 to 4, 0 to 4, negative 4. And finally, the last one. We're supposed to find a sinusoidal curve, I said A, B, C, and D here, for this data. So you go to your calculator, and you push that, and you push edit, and you enter the data. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I think I've got those in here already. And I think I also got the correct temperatures here. This is for the temperatures in Indianapolis, Indiana. Starts off 28.1, 32.1, and so on. And I put all those numbers in the table. Then I'm going to turn on a plot. So second y equals. I'm going to select plot number 1, and I'm going to make sure that it's on, that it's a scatter plot, and it's using list 1 as the x's, and list 2 as the y's. I'll come down here and do crosses. Well, maybe I'll leave them square so you can see them better on the video camera. Then the easiest to see this, I can go zoom stat, which is 7. Oh, no, that's trig. Stat is 9. There we go. And then we can see the curve. Oops. Y equal, come on. I already got something in there, so let's clear that. There's the graph. Now we're supposed to come up with the equation for that graph. But the units are kind of messed up here, so let's see. It's going from, what is our lowest temperature there? Well, if I look through all these here, it looks like the low is negative 28, or plus 28.1 degrees, and the high is 75.4. So an estimate for the amplitude would be, or the center line would be halfway between these two. So if I take and add these two and divide by 2 to get, that would give me the center line. So that would be 75.4 plus 28.1. And I have to either put that in parentheses or press enter and then do the divide by 2. It says the center line should be about 51.75. Let's take a quick look at that. I'm going to go to y equals and write in that, what was that? 51.75. 51.75 graph. Does that look like about the center? That's pretty close. So this graph is moved up 51.75. That would be my D. Now my amplitude is how far from the center line to the top or how far from the bottom to the center line. So I'll take, I have 51.75, I'll subtract the 28.1. Oops, I forgot to do subtract. Divided by 2. Subtract 28.1. And I get an amplitude of 23.65 approximately. We're doing sinusoidal. So I do sine. Now to make it have it a period, let's see, if we're doing temperatures, the period should be 12 for 12 months. And so I write 2 pi divided by 12, or pi over 6, times x. And we'll take a look at what that looks like. So clear, I'm going to have 23.65 sine pi over 6, pi times x over 6, pi x divided by 6, close parenthesis, plus 51.75. Let's see how that comes out. looks like it's about the right shape, but the sine curve starts on the center line and we need to start it near the bottom, so we need to slide this over. Looks like here's 1, 2, 3, 4. We need to move it over about 3.8 to the right. So to do that, I put the parenthesis around the x and then write, to move it plus, I got to go minus 3.8 months. So let's see if that works. So then I'm going to come in here and go down just past, I'm going to have to retype this here, so it's going to be pi divided by 6 times, now I'm going to have to insert x, what did I say, 3.8 minus 3.8, close parenthesis for that, the sideways shift, and close parenthesis for the sine, plus 51.75. Let's see how well that comes out. Graph. And that looks pretty darn good. It maybe needs to go over a little bit, but it's not bad at all. So I would consider this a reasonable effort on this and get full credit for it. Now let's just see what the calculator said it would be if I do it using the calculator. So stat calculate. Now I got to go down to get the sinusoidal curve, sine regression, and my data is in list 1, comma list 2, and then let's put the equation into y2, vars, y variables, function. I'll put it in y2 because I put my hand guessed one into y1, so y2. So now it'll figure out the equation. Now, once it's done here, let's just see how close our numbers are. For the A, it came up with 24.24. We had 23.65. Pretty close. For the B, which was pi over 6, it has 0.49. Let's see, pi divided by 6 is 0.52. Pretty close. For the shift inside here, let's see, we've got to get the equation back, so second enter. It says, come on, it doesn't take, it leaves it without the parentheses, so we would have to take our B times the C to figure out what this number is. So we'd have to take, or divided by, negative 1.9 divided by 0.49 to see what it's coming up with. Negative 1.9 divided by 0.49, and it's saying the shift should be negative 3.87. We had negative 3.8. Pretty close. And it had it moved up 51.6. We had it 51.75. Okay? That's how to do that one.